And let's look at our library again. And here we have set perspective, I believe. Yeah. So this function is gonna, you're gonna use it to create a projection matrix. So let's create a new matrix in our assignment 3. Let's call it, okay, it's gonna be left here for now. Let's create a projection matrix. Okay. Before making the matrix here, we have to make it in the shader as well. Right? So we have to make model view. Oh, we already have it here, but you have to multiply it here. So it takes effect. So it takes it actually works. So projection matrix, view matrix. Okay. And then here we're gonna have a new projection matrix. That is a new matrix 4. And we're going to call projection matrix dot set perspective to make the projection camera. And here we have 4 arguments: field of view, aspect, and this is aspect ratio, near and far. Near and far are both variables defining the 2 planes. So it's the distance to the near plane and the distance to the far plane. I think I cannot explain these concepts very well without a board and without visualizing these things. So, but basically, these 4 variables here, they defined what is called the view frustum. And I do recommend you actually, it's here you can see that it's you can see in the field of view that there is a word frustum in there. And basically, when you create a projection camera, you're gonna create a kind of a parallelogram type of shape with these variables, and this is used to transform the element to the vertices in your scene. Remember, projection and viewing, they are both matrices that are doing transformations. They're transforming the vertices. So the theory behind this perspective is explained in all the graphics books, and it's also, I think, part of the tutorial. But I wish I had a board here to really draw it. Actually, we need some extra time to explain this concept. But also, James is going to talk about this in class if he hasn't yet. But basically, we have the field of view, which is the angle of view, kind of like. And I'm gonna set this to be normally a good number here is 60 or 45, which is kind of close to what humans have. So our eyes as cameras, if you think about our eyes as cameras, we have a certain field of view. Right? We can't see 360 degrees. We can't see around our head, right? We can only see in a certain angle, which is I think around 60. An aspect ratio here, we're gonna have this. I think a good values to put here is dividing the canvas width by the canvas height. So this is gonna keep your aspect ratio always nice. So regardless of if you change your size of your canvas or not. So I think this is a good way of setting this aspect ratio. And then the distance to the near plane, I'm going to put 0.1, and the distance to the far plane is 1,000. And normally this is a very short number. This is a far number. If you change these numbers, you'll see that the perspective effect changes, and you can play with them to see how they change. And also, if you read the theory and look at the visualizations, you should be able to understand these attributes much better. But basically here, this is actually much simpler in some sense that, I mean, the function itself has only 4 arguments. So this is it. And we have to send it to the shader. So let me do this and do here projection matrix. This is going to go here. And this is projection matrix. And we have our projection matrix here. So we are sending the elements to the U underscore projection matrix. That's it. This, boom. And this is create. Oh, sorry, no. Okay, this is already here. Create a projection matrix and send it to the shader. Let me just double check that the names are matching. U underscore projection matrix, U underscore projection matrix. Good. I think that's it. So let's see. If I reload. Interesting. It's something is working. And it seems that we are kind of inside the object here. So that's why I actually had -10 here, because with the projection matrix, with the field of view of 60, and with this configuration, I think -10 is a good number. So let's put it here. Actually, it's too far now. But if I maybe -5, I'm going to get closer and closer. Okay. And if I, let's say if I move to the left, if I move to the left, essentially I'm changing I and center. Oh, here, I'm moving to the right here, sorry. I should be moving to the right, let's see. They are reflected. So I'm actually moved to the left, which means that wait, there's some things that are funny here. See that we are only seeing texture. We're only seeing the texture on one weird. It's a weird how we see the texture on the cube. And I think we forgot to do something, which is a simple configuration that we have to do. And we're going to do this in the beginning because we are working with 3D objects, and I forgot to do that before. I think, and probably you have done this as part of your assignment 2, but it's to enable depth or depth tests, basically. Test. So this should fix some of this kind of weird issues here. Let me see. Yeah. Okay, this is better. But I think we still don't see on the textures on the left and right, and I'm gonna have to see why is that. Maybe my mappings are wrong. Oh, there. Oh, I see. I only did for the I only did for the front face. So all the other ones are 0. So that's why you're only seeing the texture on the front face of the cube. But yeah, so only these guys are set. The other ones are 0. That's why you only see the texture on the front of the cube. That's something that can be fixed. But we are now, at least we can see now the other side of the cube with the camera. But something that is not very convincing to me is why when you move to the left, why when you move to the right, the camera is actually moving to the left. Right? If I move a bit more, maybe because I think we are at the back. So let me. Yeah, I think we are at the back. So let me see. 0, 0. Yeah, it's the same thing, right? If I put 1, it's gonna be. Yeah, now it's right. So now I went to the right, and then the objects went to the left. Now it's actually we are in front, which this means we are literally in front of the objects. Okay. And that's it for cameras in the sense of like having the camera in the world. Now we have to be able to move it, and basically moving the cameras is playing with these variables I, center, and up. And this is how you're gonna be able to move the cameras. As you could see, I would hard coding different numbers here, and that would move the camera left or right. But what we're gonna do is to actually control and set these numbers using the keyboard or the mouse. For example, when I press D, I want to maybe add 1 to the left, to the right here. But you see that it's not that simple. This only works if the camera is looking to the center. If the camera is like now at 00 minus 003 and looking at the center, then it makes sense to add 1 here. But if the camera wasn't at this location in the world, if the eye here, let's say if the eye was maybe 3 minus, let's see if this works, minus 4. See, now we are actually under the objects looking at the center. If I want to move right, this simply doing this won't work. Now I'm actually moving kind of backwards, right? Because the axes they changed. So we need to do some math to actually move the camera right and left correctly and forward and backwards correctly when we are in different locations of the world. And we have this math explained to you in our assignment. If you look at this part here, create camera class, this is basically, for example, here you'll see the math to compute what we call the forward vector. So every time you're moving, you have to figure out, if you want to move forward, what is forward now? If you're moving left, what is my left vector now? And here you'll see how to compute the left vector. For example, here, move right. Here's what, okay, for example, move left. You're gonna have to compute. This is the side vector. It's gonna be the up vector cross product with f, which is forward. So, anyways, we have the math here to compute these vectors to make the movements work correctly. You cannot simply just change those variables by adding. You cannot think that always you are aligned with the x, y, z coordinates of the world. You might not be aligned with these coordinates. So because of that, you're going to have to do this math here to move things correctly. And unfortunately, again, I don't have much time now to explain each one of these. And what this is saying, first of all, is to create a camera